Imagine this. The year is 1950, and you're sitting in a cafe with Enrico Fermi, one of the greatest minds of the 20th century. You're chatting about the recent advancements in nuclear physics when suddenly Fermi asks a simple question that will come to haunt humanity for decades. Where is everybody? The question refers to a strange contradiction that scientists, astronomers, and thinkers have been grappling with ever since: the Fermi Paradox. We live in a universe that is vast, ancient, and full of potential for life. Yet despite decades of searching, we haven't found any signs of extraterrestrial intelligence. This paradox stirs the imagination and invites us to probe not only the cosmos, but the very nature of life and intelligence itself. So, what is the Fermi Paradox, and why does it continue to baffle us? 1. The vastness of the universe. First, let's step back and consider the sheer scale of the universe. Our galaxy, the Milky Way, contains about 100 to 400 billion stars, and there are over 100 billion galaxies in the observable universe. So, in total, the number of stars is well over 1 quintillion. 1 quintillion stars. Many of those stars have planets orbiting them. In fact, scientists estimate that there could be billions of Earth-like planets just in our own galaxy. This isn't just speculation. The discovery of exoplanets, planets outside our solar system, has accelerated in the past few decades. By 2023, we've confirmed over 5,000 exoplanets. Many of these are located in what we call the habitable zone, where conditions might be right for liquid water to exist, an essential ingredient for life as we know it. So when you add it all up, the universe seems ripe for the existence of other civilizations. With so many potentially habitable planets out there, why have we never detected clear evidence of alien life? 2. The paradox. This brings us back to the Fermi Paradox. If the universe is so teeming with planets and the likelihood of intelligent life is high, then why haven't we heard from them? Why hasn't any extraterrestrial civilization made its presence known? The paradox lies in this tension between what we expect, the high probability of alien life, and the absence of evidence for it. We've sent out signals, listened for radio waves, launched probes, yet nothing. So, what are the possible explanations? Let's explore some theories. 3. The Great Filter. One possibility is that there's something preventing life from reaching the stage where it becomes detectable. This is known as the Great Filter hypothesis. The idea is that somewhere along the path from basic life forms to a technologically advanced civilization capable of space travel, there is a filter that few species can survive. Perhaps life starts easily, but intelligent life or technological life capable of sending signals into space is incredibly rare. Maybe the great filter lies in the leap from single-celled organisms to multicellular organisms, or the jump from simple tools to advanced technology. Or it could be that the filter occurs after technological civilization arises. Civilizations could be self-destructive, for instance, by war, climate change, or some other catastrophe. In this case, we might be living in a rare moment in history, one of the few civilizations to survive long enough to reach out. If the Great Filter is ahead of us, it would mean that humanity is at risk of encountering that obstacle. Perhaps we haven't reached it yet. On the other hand, if the filter is behind us, we might be one of the lucky few civilizations to have passed through it. 4. The zoo hypothesis. Another intriguing possibility is that extraterrestrials are already aware of us, but they're intentionally avoiding contact. This is known as the zoo hypothesis. Just as we observe animals in the wild without interfering with their natural development, alien civilizations may be deliberately staying hidden, allowing us to evolve without interference. The idea is that we are like a species in a zoo, being observed from afar, but not yet ready for discovery. This idea raises interesting ethical questions. If advanced alien civilizations are observing us, would they have the right to make contact? And if they do, what would happen to human society? Would it be a peaceful interaction, or would the shock of discovering we are not alone in the universe be too much for us to handle? 5. The rare Earth hypothesis. Another theory that tries to explain the paradox is the rare Earth hypothesis. According to this idea, the conditions that allowed life to evolve on Earth might be incredibly rare in the universe. While it's true that there are many planets out there, the specific combination of factors that allowed complex life to emerge on Earth, like a stable climate, a large moon to stabilize the planet's axis, plate tectonics, a magnetic field, and the right chemical conditions, could be so unique that it's unlikely any other planet has the same configuration. This theory suggests that while microbial life might be common, complex, intelligent life capable of building civilizations is exceedingly rare. So, we might just be alone in this part of the universe and possibly even in our galaxy. 6. Self-destruction and the longevity problem. Let's consider another possibility. Perhaps civilizations are not rare, but rather they tend to destroy themselves before they have the chance to become detectable. It's a sad but plausible scenario. Look at our own history. As technological civilizations advance, they gain the ability to self-destruct through nuclear war, environmental collapse, or other catastrophic events. For instance, could nuclear technology be a common discovery for advanced civilizations? And if it is, does the ability to destroy oneself before achieving interstellar communication lead to the extinction of that species? This could explain why we don't detect signals. Civilizations just don't last long enough to develop technologies that can reach us. 7. We're looking in the wrong way. What if we're simply not looking in the right way? Our methods of searching for alien life, radio signals for example, are based on the assumption that alien civilizations would communicate in similar ways to us. But that assumption might be flawed. It's possible that alien civilizations are using technologies far beyond our imagination, and we simply don't have the tools to detect them. Perhaps they're using communication methods that we haven't even considered, like quantum communication or some form of transmission we can't yet understand. Alternatively, maybe the aliens don't even want to communicate. Maybe they are so different from us, so incomprehensible in their biology or culture that we can't even recognize their existence. 8. The simulation hypothesis. One final, somewhat mind-bending possibility is the simulation hypothesis. What if the universe itself is a simulated reality and we are simply part of a computer program run by an advanced civilization? If that were true, the lack of extraterrestrial life might be because the simulation creators deliberately programmed the universe to appear lifeless or devoid of other intelligent beings. This could be part of the simulation's design, or perhaps even an experiment to observe how we behave. Brief pause. 9. Conclusion. The mystery continues. Ultimately, the Fermi Paradox raises more questions than answers. It challenges our assumptions about the universe, life, and our place in it. Are we truly alone? Are advanced civilizations so rare that we're the first, or are we simply not looking in the right way? The search for extraterrestrial intelligence is far from over. With advanced telescopes like the James Webb Space Telescope and growing efforts to explore the outer reaches of our solar system, we might be on the brink of discovering something profound. Until then, the Fermi Paradox will remain one of the greatest mysteries of science, a riddle wrapped in the vastness of space.